Hi guys, this is GK from GK Marine Tech. Today's lesson is three-phase AC. So what is this three-phase AC? First we will see that how the AC is generated from the alternator. We used to call alternator because it is generating AC. If it is generating DC, we used to call generator. Okay. So first we will see how it is generating the electricity from the alternator. So the basic thing they used it is a magnet. Okay, this magnet, first you understand the magnet how it is. Normally one magnet will have two poles, right? It is a north pole and south pole, and there is a magnetic flux lines. It's invisible lines, and you can say imaginary lines also. So the lines is starting from north and it is going to the south. And one more thing, this line will not intersect with another lines. This is a normal principle of magnet and magnetic flux. This lines is called magnetic, this area is called magnetic field, and this line is called magnetic flux line. Okay. So this flux line is very important. This will depends upon the strength of the magnet. Okay, so now we are using the permanent magnet, but in future videos I will tell you without magnet how you make the magnetic field. With the electromagnet it is to call. If you supply the electricity, then it will become a magnet. That is called electromagnet. This is the permanent magnet. Okay. Now we will understand with the permanent magnet, and future videos we will see about that how electromagnet is using for the alternator. Okay. So you understand now this lines. This how many lines we don't know. It is around the 360 degree. This magnet is square or round, whatever it is. It will start from the smaller end and north side to south side. Okay. So we are going to use this magnet to produce electricity. How we are using, and as per Faraday's law, you know that if you move this magnet near the induction coil, so if you can rotate this magnet, for rotating magnet we need some prime mover, that can be engine, turbine, whatever it is, but we have to rotate the magnet with the other means. Okay, then only it will produce the electricity. Okay, now I am going to use this magnet with magnetic field. It is a permanent magnet. So how we are using, I will tell you. So now I am going to rotate the magnet, same magnet, inside the two coils which is connected in series. Right? Two coils we connected in series, and we are rotating the magnet in center of that. Okay? So what is going to happen? If you rotate it, this line is going to cut this conductor. Okay, conductor, this, if you line cutting this conductor, then the conductor there will be a EMF induced in that is a Faraday's law. So now I am going to rotate in clockwise direction. See, then now the magnetic field is strengthened in this between these two magnets, right? The center one is the middle one, there is no magnet. The center one is the axis of the magnet, there the magnetic flux line is very weak. So that line is not going to do anything. The north, from north side, north pole, the magnetic flux is coming to the south pole. The middle of the portion, it is having a strength magnetic flux field. So that field, when it is coming here, that time you see that the voltage is generating. Now I made it only one phase. So this is called single phase alternator. So one phase, what is happening? North to south. That line, north to south, the arrow mark is the reverse side, left side. This arrow mark crossing time, the voltage is coming in the positive, and it is coming here, and here in the neutral axis, then the voltage is 0. Then again the south to this reverse action, the arrow mark is the right side, so the voltage is coming in the negative direction. So this is the way, and I shown here also current which side it is moving. That is also I shown in the animation. I think this is very clear for single phase alternator, but we are going to make a three phase. Three phase in the sense we are going to delay. How we are going to delay? We will position the coil. I am going to make one more coil here. See, now I made one more coil, and I made it a color. But normally we used to differentiate. All wires are same only, but we used to differentiate. There is a standard notation RYB. R is the red color, Y is yellow color, B is the blue color. So we are denoting the coil with the colors and the letter. So that doesn't mean that wire should be in that color. Wire is a normal conductor only. We are mentioning that coil is the Y phase and yellow phase, red phase and blue phase. Okay, RYB we used to call. Okay, now yellow color, that's for easy understanding. I made that color the same notation only. So yellow color I made it 120 degree. because this is a 360 degree. So we want 3 phase. So we have to equally divide the 360 degree. 360 by 3 phase, it is 120 degree. So I made the coil in 120 degree. Right. So what will happen? First the electricity will produce in this coil after 120 degree delay. After 120 degree of rotation. Then this coil, the same manner, this coil will produce the electricity. See? What is going to happen? You see, red and yellow both is used to come. See? First yellow has come. After 120 degree, this is a time scale. After 120 degree, the yellow is come. Okay. Now yellow is the same. North to south, the coming, that time yellow is negative. See, south to north is negative. North to south line crossing the yellow, then you will get the positive. So this is the method. Normally the alternator. This is why we are calling it as alternator. I already told you. If it is producing AC, that is called alternator. If it is producing DC, that is called generator. Okay, that is easy for identifying. Okay. Now I made it only 2, but I want one more. No, one more gap is there. So I am making the one more. That is a blue winding. Now you see, we have a 3 windings with 3 series of windings. One winding is having 2 poles. Okay. So now this 2 windings is series, connected in series in such a way the output will come in the sine wave pattern. Now you see all 3 how it is producing. Wherever north to south flux is crossing, that time maximum peak voltage is coming. And south to north crossing, that time negative peak voltage is coming. See, very simple. And the direction, red direction only I shown. The direction and the amplitude also I shown in the output. This is the output we are going to use in the load. Now 3 phase which is having 120 degree, 120 degree, 120 degree time lagging. Time lagging in the sense one frequency only we are calculating. Last class also I told we will consider one frequency only. One frequency is 360 degree. And 360 degree if you divide into 3, then the time difference between or degree angle difference between 2 phases will be 120 degree. That is why it is 120 degree. We can make it is 120. I will show you. I will show you the big the screen in this how 120 degree it is coming. So I am going to draw here the first red one. Okay. So red one is started when it started 0. We are taking it as a reference line. The red will start. So red will start, it will complete in 360 degree. That is one cycle. But if it after it red started, after this 360 degree divided into 3 part, then your 120 degree will be come here. 120 degree will come here approximately because this is 90. This is 120 degree. This is 120 degree. This is 120. This is 120. So now next sine wave will start from here because this is a time scale. Right. So I'm next where it is starting. See, yellow is started in after 120 degree. This is different. And last class we saw about the cos phi power factor. That is the waveform. That is also difference between the waveform. But this is a voltage to voltage different. That one voltage to current different. Don't confuse with that. That also in the section last section we will see. Current and voltage difference is called cos factor, power factor, cos phi, power factor, everything last class we saw. So now this is the phase difference, phase angle difference between 2 phases. Okay. Now third phase will become like this. Now you see, first phase 120 degree delay, second phase 240 degree delay, third phase again it is new cycle has started. Got it? Very simple. Is a 3-phase diagram like this only it will be there. So now we will see furthermore how to change this pattern, into the vector diagram. Already I told you phasor, vector both are same only. Vector diagram means we are single line because this is a curve, no? So either arithmetical calculation is very difficult. Mathematical calculation if you want to do, it is very difficult. So we are converting this drawing into single line diagram. That is called phasor or vector diagram. That will show the magnitude. And single line will show magnitude with the direction, which angle, which degree it is started. That is particular. Suppose a yellow means yellow direction. I will tell you now. See now 3 phases I shown here. This is red. This is red. This is yellow because always this angle, this vector angle will rotate in anti-clockwise. Remember that one always, because it is a standard. You don't ask why it is rotating in anti-clockwise. Always it is rotating in the anti-clockwise. So if it is anti-clockwise, then LO is behind, 120 degree behind, because here 120 degree behind. So here 120 degree, 120 degree, and this is LO, and blue one 240 degree. 240 degree, we should not angle measure like this. We have to measure angle like this. 240 degree. Understand? So how much lagging only we have to tell. Advance we should not say, because of the vector is revolving in the anti-clockwise, counterclockwise direction. Okay, now we will go ahead with the still more how to calculate the difference between the phase from this phase and this phase, between how much voltage is there, because both are voltage, no? But both are not same. See, here maximum is there. You can make it here. Make it here. You see here. Here blue is little bit positive, yellow is positive. Same time, red is negative. So all together, if you check the voltage, this voltage, blue voltage, yellow voltage, plus means minus, red is in the minus red voltage will become 0. That I will show you. So three phase diagram, this is the 120 degree. I am going to draw the vector diagram now. So vector diagram, before drawing the three phase diagram, we have to make a symbol like this, star connection, because one thing I remember, always alternator mostly connected in star configuration only, because it is having a center point we are going to use as a neutral. That is why always is not in the delta. We are going to talk about star, what is star, what is delta. Star means like this connection, this Y shape. Okay, so now I am going to draw all the three phases out. So this is the alternator, and we are going to produce three phases out. But one more line we can take from the center. The center line always will be 0 volt. Reason behind, all three is connected together in the same point. I told you all together volt, if you add it, the answer will become 0. So that is why this point we can take it as a neutral. So this is the phase line, this is one phase line, this is one phase line. The difference between voltages are same, but the difference between the time lagging 120 degree time lagging between each other. So the neutral line, if you take it, it will become a 0 volt. There is no volt. We can take it as a reference. Got it? So whatever the current is passing here, you can return back through the neutral. That is the idea. Okay, this is a called 4-wire system. And if you connect it delta means it is like a triangle. Next lesson we will talk about detailing. Okay, delta we cannot give this neutral. So our power supply always will be in this like 4-wire system. In ship we don't connect this. That we will future lesson I will tell you that what is that called. It is called isolated earth. We will discuss about in the future videos. Okay. So now voltage. We have to tell the voltage. This is called line voltage. If you mention it is VL, that is called line voltage. If you not mention, suppose mention only V, also line voltage only. Okay. So this is line voltage means between the phase. So this is also line voltage. This is also line voltage. This voltage normally will be very equal. Balance load and normal alternator, it will produce three phases, same voltage only. But current accordingly, with this phase how much load is connected, this phase how much load is connected, depends on that the current will vary. Current will not be equal, but whatever our discussion, all balance load means all three phase, it is consuming the same equal current. That condition only we are going to discuss. Okay, but practically it is not possible. Okay, now this is a VL and between blue and yellow also VL. Okay, this is called line voltage. The letter noted is V, only V or VL. And between blue and R means we have to write B minus R. That means difference between phase B and phase R. We are going to see now. Okay, now what is this? Any phase, any three phase, any phase you take it, phase one reference and neutral one reference. This is called phase voltage, because this is one phase, this is one phase, this is one phase. We are going to measure this voltage or this voltage or this voltage. Now I mentioned this red and this voltage. Okay, this voltage I mentioned now. This is V phase voltage. That voltage only I mentioned, because here red I put it and green I measured it. This is called phase voltage. This letter denote compulsory, we have to mention PH. If you are not mentioning, that will become a line voltage. Okay, this VPH will be definitely, because this is in the series now, so the voltage will be in the middle of this line voltage. If suppose line voltage is 420, then middle of this 220 to 220 voltage will be there. Okay, so now this is called phase voltage, line voltage, and RYB 3 phases, neutral 4 wire system. Okay, so now this also phase, between these also phase, and between blue and this also green reference. If you are taking green, neutral, that is called phase voltage. Our houses and all, we are using 220 volt, this phase voltage only, and we are using 3 phase motor, then we are using line voltage, but both is coming to our house. See, this is 220, this is 450, but one thing you see that this is 220, that means it has to be double, no, because the same coil, but that is not vector angle is different, phase angle is different between the phase, right, voltage. So we cannot add directly. Last class also we saw how to add vector quantity. So vector quantity, if you add it 220 plus 220 in vector measurement method, then you will get it 450, not 440. Otherwise 220 plus 220 440, because here 220, here 220. So between these 2 points it should be 440, no? It will not be 440, it will be 415 because of vector addition. We are going to see how they are doing the vector addition. See, now I am taking this one. I am going to now calculate VRY. VRY means what? Between V phase and R phase, how much voltage? That is called line voltage. We used to call line voltage. How to calculate from the vector addition? You will see. I already told you the vector is always revolving in the anti-clockwise direction. I shown only the red phase. Now I am going to start the red phase. Red phase, if it is touching 120 degree, 120 degree approximately will come here, right? And 240 degree will come here. Sorry, here. 1 minute. This is 240. This is 240. This is 120, because we have to measure like this. Already told you, because it is rotating here. That is why I am measuring, because the one phase is ahead, it is leading, and other phases are lagging and following that first phase. That is the funda in the 3 phase diagram. So here, now what I am going to do, I will erase this all. Otherwise it will get confused. Now I am going to start the vector revolution. Then you see that what is happening when it is coming here, the yellow will start. See, if it is coming here, you see yellow will start, right? And yellow is coming here, then blue will start, and it is going to the final position. That means what? Here the yellow is, this yellow is, wait a minute. So the yellow, the yellow is 120 degree lagging from the red, and blue is another 120, that is 240, 120 plus 120, 240 degree lagging from the red phase. So this is the idea to understand the phasor diagram. Okay, so now what we will do, I am going to calculate the voltage difference between red phase and Y phase from the use of vector diagram. So I already made the vector diagram. Now I am going to add both phase, but here see the difference only we want. We don't want add. We want the difference between red phase and voltage of red phase and voltage of Y phase. So difference means minus, no? So we cannot minus. Parallelogram theorem, we know only the plus. So what we are going to do, we have to take out this minus. How to take out, I will show you. VR minus Vy, we are going to take out this minus, make it plus. See how we did, very simple, it's a max. So we put it plus and bracket we put it minus. Okay, so you can ask now why we are doing like this. So minus Vy, that means what? Negative direction of Y volt. Negative direction of Y volt. This Y volt is this one. In this, for this negative direction, what? This direction is this side. This opposite direction. Opposite direction is the minus Vy. Like that, red minus this side minus red. This side minus blue. So I am going to make a minus Vy line, the same magnitude. How much voltage is there? Same magnitude, but opposite direction of this, 180 degree opposite to that phase. So now you got it, one imaginary line minus volt and one red line. Now you know the parallelogram theorem. So you can make the shift this line and this line parallelly. Then you make it diagonal. The diagonal is called the resultant. Okay, this is a simple mathematics. So this is the result. This is the voltage between red phase and Y phase. The direction will be 30 degree. How it is 30? This is 120, this is 90, and this is 30. So this is also 30. This is also 30 degree. So if you 90 degree minus 30, this will become 60. 60 divided by 2 will become 30. So 30 degree, it is the angle of that. So with that 30 degree and red, you have the red phase voltage. So you can calculate the resultant voltage with the use of 30 degree. Now I think you got that idea how they are calculating the difference between this. Because of this, because this one 220 volt, this one 220 volt, this one 220 volt. This 2 is 220 volt, 220 volt. But we are not adding directly, no? We are adding vector quantity. So this both add with by vectorly, then the answer will become 415. 415. Not 440. Got it? So this is the way vector addition. So I put it already 415. And the 415, what is the 1 minute? I will erase that markings. Okay, all marking, I will erase it. Okay, so now you see here 415, the relation between 220, the relation between 220 and 415, root 3, 1.732. That's our mathematical calculation. There is a procedure is there, method is there to calculate that. So you can simply root 3, if you root 3 VR. Root 3 VR means what? Your 220 volt, normal volt, red phase volt. Red phase volt is 220 volt. So you have to multiply by root 3, you will get it 220 into root 3, 220 into 1.732 equal to 415 volt. That is why it is come 415, not 440. You have to understand this. We cannot add directly. Okay. Now you got, I think you got the idea how vector addition, how our three phase voltages become 415 and single phase voltage it is 220. Okay. So now three phase volt and current. How to measure? See, now up to now we saw difference between the comparison between the phases, all voltages only. We didn't talk about the current. So like each phase is having its own current, depends on the load is connected to that phase. So first we will make a red, we will take the red phase. So red phase, it is a voltage curve. So if you add the current curve, the current curve will come like this. This is how we saw in the last video. So current curve will be delayed by 1 degree. This is the power factor angle, right? Cos of this angle is called power factor. There is a delay because of inductive load. Okay. So this is for red, not all. Okay. So now if you put it yellow is having a separate current curve. Like Blue is having separate current curve, but mostly all this phase angle will be same, but that is also will vary, depends on the load, the phase, power factor angle also will vary. This is called power factor angle. Power factor angle will vary, depends on the load. If that's why already I told you, we are discussing only about the balance load for just for understanding, but it will not be, it never be the balance. So each phase power factor will be different. Okay, this is the three phase voltage and current curve, how the waveform is there, sine wave. Okay, so now I am going to take one position and I am adding all voltage or I am adding all current. Current will become 0, voltage will become 0. That is a funda. If you want to measure voltage or current, individually you have to mention. You cannot measure all together. If you add all the voltage vectorly, finally your answer will become 0. Because here positive, one voltage is negative. Like that same current also. Both two currents are positive, one current is negative. So that will, both the positive current is equal to the negative current. So if you add both the all current together, then you will get answer 0. So if you want to measure with the tongue tester, if you want to measure the current, you have to measure individual phase, separate, not like no, together. So in practical issues, we will see that how to measure when motor is running, how to measure the voltages, current. Total voltage is 0. Okay. 3 phase power, what is the formula? 3 into phase voltage into phase current into cos phi. Cos phi is important because here cos phi is there, I told you, that is energy efficiency power factor. And 3 phase power, if you calculate, if you know the phase voltage and phase current, then is the formula. Or if you have the line voltage and line current, you have to multiply by 3, root 3. And cos theta is must for 3 phase. 3 phase or single phase. For AC, cos theta is must. This is the 3 phase power factor, 3 phase formula. I think almost I cover up all, and we will talk about the advantages of, okay, advantages of 3 phase. Why we are not using the single phase? Why we are developed to the 3 phase? Just we will, it is smaller in size, because single phase, the winding connection, everything will be huge. So the weight to power production ratio, if you see, this is better. 3 phase is better. The size is very small, producing more power than the single phase. Size will be bigger, producing the same power. Okay, so smaller in size. Self-starting, that is a big advantages of this. Single phase, we have to make some arrangement to start. Okay, but this 3 phase, it is a self-starting because it is having a phase difference phase we have with the time lagging, time difference. So we can make magnet here first, then here, like that we can switch over the magnet very easily without moving physically. We are going to see on a few future videos very soon. We are going to discuss about how with this 3 phase on AC motor is running. Okay. So now self-starting with rotating magnetic field is possible in this 3 phase. Balance load is possible because 3 phase is there. We can make it a balance. We need not to put one phase only all the load. We can balance the load means we can divide the load. We can distribute the load in 3 phase so that we can get better balance. Can use single phase motor also because the alternator, we have 4-wire system, we have a neutral line. So any one phase and neutral, if you take it, it is a 220 volt like our houses and all we are using. So we can use a single phase motor also. We can use 3 phase also. Between the RL, VL, BL, all 3 if you directly using, that is a 3 phase. If you are any phase and one neutral if you are using, that is a single phase. Low current starting possible. That future video, star delta, starter, we are going to see. So when you are starting, the motor current will be more. But in this method, we can start with the low current, then we can pick up to the full current. And reversing motor, very easy. We are going to see in the future videos how to reverse the induction motor just for 2 wires, R and Y or Y and B or B and R. Any 2 wires, if you swap, then the direction of the motor will change because the sequence, this is the first one, second one, third one. If you change it like this, then first one, second one, third one, like this will come. It is a sequence order. That order, if you change it, that motor direction also will change. Now I think you got a better idea in the three-phase system. It is very important. Next one, we will see about the star connection and delta connection. What is the difference and why we are doing? What is the advantage difference between? We will catch you in the next video about the star delta. Thanks for watching.